You know what's funny? Everyone thinks time moves forward. Past, present, future like beads on a string, one after another. We're so sure about it that we built our entire civilization on this idea. Our clocks tick forward. We age forward. We remember backwards but never forwards. But here's the thing that'll make your head spin. The fundamental laws of physics don't care which way time goes. I'm not joking. Every equation we've got, Newton's laws, Maxwell's equations, even Einstein's relativity, they work perfectly fine whether you run time forwards or backwards. It's like watching a movie in reverse. If you're watching billiard balls bounce around, you can't tell if I'm playing the film forwards or backwards. The laws don't know the difference. So if physics doesn't prefer one direction of time over another, why the hell do we experience time flowing in only one direction? Why can't we remember tomorrow? Why do eggs scramble but never unscramble? The answer isn't what you think. And when you understand it, I mean really understand it, you'll never look at a cup of coffee the same way again. Let me show you why everything you think you know about time is completely backwards. Okay, so let me start with something simple. Drop a glass on the floor. What happens? It shatters, pieces everywhere. Now, have you ever seen those pieces jump back up and form a perfect glass again? Of course not. That would be absurd. But here's where it gets interesting. Show me the law of physics that forbids this from happening. Go ahead, I'll wait. You can't, because there isn't one. If I took a film of that glass shattering and played it backwards, every single atom would be obeying Newton's laws perfectly. Every collision, every bounce, every movement, completely legal according to physics. The equations don't care. So what's stopping the glass from unbreaking? Why does it feel impossible even though the laws of physics permit it? The answer is probability, and this is where entropy comes in. Now, I know what you're thinking. Oh God, not entropy. That's complicated. But it's not. It's actually one of the simplest ideas in all of physics. And people make it sound complicated because they like to feel smart. Here's entropy in plain English. It's a measure of how many ways you can arrange things. Think about your desk. There's one way to have it perfectly organized, every paper stacked, every pen in its place. But there are millions of ways to have it messy, papers scattered, pens rolling around, coffee stains everywhere. That's it. That's entropy. More ways to be messy than to be organized. Now apply this to the glass. When it's whole, all those trillions of atoms are arranged in one very specific way, a glass shape. But when it shatters, those atoms can be arranged in an astronomical number of ways, scattered on the floor, different sized pieces, different positions. The number of possible arrangements is mind-boggling. And here's the key. Systems naturally evolve towards states that have more possible arrangements, not because of any law that says thou shalt increase entropy, but simply because there are more ways to be there. It's like saying if you shuffle a deck of cards, you're unlikely to get them in perfect order. You could, there's no law against it, but the odds are stupidly small. So the glass doesn't unbreak, not because it's forbidden, but because there are so many more ways for it to be broken than to be whole. The odds of all those atoms randomly bouncing back into exactly the right configuration, you'd have to wait longer than the age of the universe. Many, many times over. But notice what I just did. I explained why things go from ordered to disordered, from low entropy to high entropy, and that is what we call the arrow of time. Time doesn't flow forward because of some cosmic river. Time appears to flow forward because entropy increases. We remember the past, but not the future, because our brains are physical systems that also obey entropy. Memories are low entropy configurations. Making a memory increases the total entropy of the universe. Now here's where it gets really wild. The Big Bang, the beginning of our universe, was in an incredibly low entropy state. Everything was compressed, ordered, organized in a very specific way. And since then, the universe has been spreading out, getting more disordered, increasing in entropy. That initial low entropy state is the reason we have an arrow of time at all. If the universe had started in a high entropy state, maximum disorder, there would be no arrow, no direction. Things would just be static, random fluctuations going nowhere. So the question isn't, why does time flow forward? The question is, why the hell did the universe start in such a low entropy state? And that, my friends, is one of the deepest unsolved problems in physics. We don't know. We have ideas, inflation, quantum fluctuations, multiverse stuff, but we don't know. Let me give you another brain bender. In quantum mechanics, we have this thing called time reversal symmetry. Most quantum processes work the same forwards and backwards. But there's this tiny, tiny exception in certain particle interactions, kaons, if you want to look it up, where time reversal symmetry is violated. It's a subtle thing, and honestly, it probably doesn't matter for the everyday arrow of time we experience. What matters is entropy. But here's something even stranger. In my work on quantum electrodynamics, the theory of how light and matter interact, I found that you can think of antimatter as ordinary matter going backwards in time. A positron is just an electron running backwards through time. I know. That sounds insane. But mathematically, it works perfectly, and it led to some of the most accurate predictions in all of physics. When you do the calculations, you can't tell if you have an electron moving forward in time or a positron moving backward. They look identical in the equations. So in some sense, at the quantum level, time isn't this one-way street we think it is. Particles can, in a very real mathematical sense, move both directions. But when you have trillions upon trillions of particles, macroscopic objects like you and me in coffee cups, the statistical weight of entropy dominates everything, and we get our familiar arrow. Here's what kills me. We built this whole edifice of human experience on the idea that time flows forward, cause and effect, history, progress, aging, death, all of it assumes this directionality. But at the fundamental level, the universe doesn't give a damn which way time points. It's only because we started in a special low entropy state that we have this arrow at all. And one day, far in the future, when the universe reaches maximum entropy, heat death we call it, there won't be any meaningful arrow anymore. No change, no events, just equilibrium. Now let's talk about what this really means for how you experience reality. Because once you understand this, you can't unsee it. You think you're moving through time, right? Like you're on a train and time is the track. Past is behind you, future is ahead. That's how it feels. But that's not what's happening. Not even close. What's actually happening is that entropy is increasing around you, and your brain interprets that increase as time passing. You're not moving through time. You're just sitting in an evolving universe that's gradually becoming more disordered. And your consciousness is along for the ride. Let me make this concrete. Take memory. You remember eating breakfast this morning, right? Why can you remember the past but not the future? People say, well, that's obvious. The past already happened. But that's circular reasoning. That's just restating the question. Why has the past already happened and the future hasn't? The answer is entropy again. A memory is a physical structure in your brain, neurons configured in a specific way, chemical pathways established. Creating that structure increases the entropy of the universe. The act of remembering involves accessing a low entropy configuration that was created earlier. To remember the future, you'd need your brain to contain low entropy structures that correspond to events that haven't happened yet. But how would they get there? They can't. The only way to have information about a state is for that state to have affected you, to have left an imprint. And that only works in the direction of entropy increase. So you remember the past because the past was lower entropy than now. And high entropy systems can contain records or traces of their lower entropy past, but not their higher entropy future. Here's something that'll bake your noodle. If you could somehow reverse the entropy of your brain, make it evolve backwards, you would start remembering what we call the future and forget what we call the past. From your perspective, time would be flowing the other way, and you'd be absolutely convinced that you were still moving forward through time. There is no privileged direction. The arrow of time is a statistical phenomenon, not a fundamental feature of reality. Now, you might be thinking, okay, Feynman, but I still experience cause and effect. I drop the glass, then it breaks, not the other way around. True, but that's still entropy. The cause is a lower entropy state, and the effect is a higher entropy state. You only perceive causation in one direction because entropy only increases in one direction, statistically speaking. Let me tell you about something really weird. In quantum mechanics, we have what's called the Wheeler-Feynman absorber theory. My old professor John Wheeler and I worked on this. The idea is that electromagnetic radiation doesn't just go forward in time from source to receiver, it also goes backward in time from receiver to source. Wait, what? Yeah. The math shows that electromagnetic interactions can be described as waves going both directions in time, and they meet in the middle to create what we observe. The reason we only see radiation going forward is, once again, boundary conditions and entropy considerations. The universe's initial low entropy state picks out the direction. This isn't science fiction. This is what the equations tell us. And it led directly to the path integral formulation of quantum mechanics, one of my biggest contributions to physics. In that formulation, particles don't take one path from A to B. They take all possible paths, including ones that go backward in time, loop around, do crazy things. We sum over all of them to get the final answer. Time, in quantum mechanics, is even stranger than you thought. But let's get back to something you can grab onto. Imagine you're watching a movie of the universe. Not our universe, a simple universe with just a few particles bouncing around. If I show you a clip from the middle of the movie, can you tell me which direction is forward in time? If entropy is increasing in one direction, yes, you can point and say, that way is the future. But if you catch a moment where entropy happens to decrease slightly, totally possible for a small system, you'd point the wrong way. The arrow of time is an emergent property of large systems, not a fundamental feature of the film. Our universe is a very, very large system. So the probability that entropy decreases macroscopically is essentially zero. Not exactly zero, remember. The glass could reassemble, but so close to zero that it might as well be. Here's what keeps me up at night. We have no idea why the Big Bang was low entropy. That's the real mystery. Some cosmologists think maybe the universe is cyclical. Big Bang, expansion, contraction, big crunch, then another Big Bang, and maybe entropy resets somehow. Others think we're in a multiverse, and different universes have different entropy gradients, and we're in one where the gradient creates conditions for life. Because here's the thing. If there's no entropy gradient, there's no arrow of time. And if there's no arrow of time, there's no structure, no complexity, no life, no consciousness. We exist because the universe started in a very special, very unlikely state. Some people find that comforting. I find it disturbing. The entire human experience, every thought you've had, every person you've loved, every moment of joy or sadness exists only because of a cosmic accident of initial conditions. We're riding an entropy wave from order to disorder, and we call that wave time. And here's the final kicker. According to relativity, time isn't even universal. There's no cosmic clock. Different observers moving at different speeds experience time at different rates. What's simultaneous for you isn't simultaneous for someone moving past you at high speed. So not only does time not flow forward in any fundamental sense, but there's not even agreement on what now means. The present moment, the thing you're experiencing right this second, isn't a universal feature of the universe. It's local to you. Put it all together. Time doesn't flow. The arrow of time is a statistical illusion created by entropy. The direction of time could be reversed with the right conditions, Quantum mechanics allows for backward time influences, and there's no universal now. Everything you thought you knew about time, wrong, or at least drastically incomplete. The universe is far stranger than you imagined, and far more beautiful.